All right, so next up we have Team Barkeshli's Bouncing Balls, led by Firoozi. Their project is an NBody gravity simulator. Their pitch is going to be done by Erika and Jason. Team Barkeshli's Bouncing Balls, you have 3 minutes.
Hi there. So our project aimed to solve the NBody problem, which if you don't know what that is, the NBody problem is basically like, let's say you generate a planetary body, right? Like a moon, planet, etc. And you have another one, right? So how are these going to move according to each other's mass and according to their distance, right? So what we did is we wrote these functions by scratch, where basically we're updating constantly the velocity and the acceleration, and we're checking to see just how the mass is affecting every other particle. So it's basically going through and updating all of the particles you see on the screen. So what we started off doing is we tried to do the solar system, right? Well, it turns out that the solar system is a very complex thing to model. The solar system, as you know, has the sun in the center, and then light years away has, you know, the first planet, the second planet, etc., etc., etc. And we found this to be hard. But we did get sandbox working, where we're able to show just exactly what happens when you generate different particles of different masses. And that's what we're showing right here.
Can you turn off the lights?
Oh, could you lower the light, please? So you can see the button?
So this is our sandbox, and so all the different color balls are they have different masses, and we can add new bodies by selecting their size and setting their velocities by dragging that pad. Oh yeah, so depending on how far you drag the mouse before releasing it, will determine how quickly it can make. So we've actually had this program running for the last 15 minutes or so, and as you get farther out, you'll notice that these, originally they all have velocities on the outside, but it kind of will just come to a state of rest when they're, I guess, the appropriate distance away from each other, which is pretty cool. But you can still add more out there. You should. Sorry. You can't see any red? Oh no. So there's 4 colors on our screen.
I don't know what's going on.
That's weird.
Like above right here, there should be a red particle. It's showing up on our laptop, but it's not showing up on the projector.
Can you see that one? Oh, there you go.
Okay, let's see.
So, yeah, the scale is kind of weird because like you have to imagine the distances between these two particles is really, really far. So they kind of behave in really strange ways. Sometimes they'll start, orbiting around each other. We had kind of we started mocking up the solar system. We had the sun and the Earth. It was like super boring because it doesn't look like this at all. So you have to kind of have to hard code in some extra numbers, which would, thinking about how we would take this in the future.
Team Barkeshli's Bouncing Balls, that is 3 minutes. We're now going to open it up to 2 minutes of questions from the judges.
So who do you imagine using?
Different groups of people can use it. It can be used for educational purposes at schools, from elementary to the university, because I'm imagining that it's really hard. It was really hard for me to imagine how each planet is reacting in according to other planets. The thing that we were trying to prepare was the solar system, but because of the skills that are humongous, it was really hard to show it and demonstrate it on the screen. So to show the solar system to a student and explain how the particles work toward each other is a lot easier compared to the time that you only have them printed in a book.
I know very little about this subject, but looks cool to me. Did you solve the NBody problem? Because I saw a small green moon pass by a blue planet.
Okay, that's exactly because of the scaling. Because we changed the scales of the planets, so we can see it on the screen. If we zoom in, you can see that they're actually far away from each other, the same way that you're seeing the stars. So when when they are colliding in this system, we only demonstrated the full collision, which is one particle get absorbed by another particle. So we are gonna leave this program run for a few days, and hopefully we can catch a black hole, because we didn't add any limit to it, and the density of the particle will increase while the size of the particle doesn't change.
Thank you.
All right, let's give it up for Barkeshli's bouncing ball.